Hi everyone, this is in case you missed the Google Meet this week or if you just wanted a refresher while you're doing your puzzle piece. So the first slide, look at the triangles shown below. In your notes, write two statements. One, how are the triangles the same? Two, how are the triangles different? When you are finished with today's lesson, revisit this activity in your notes and see if you can add any additional comments. All right, so I will let you do that on your own, but I do want you to look at this triangles and this triangle. All right, so it says find the distance between the 2 points. Now, believe it or not, this is actually very similar to Pythagorean theorem. We've actually already been doing this. This is just a way, in case you were given 2 points without a triangle, you could solve it. So we'll get to this formula in a second. First, I want to refer back to a squared plus b squared equals c squared. Now you're saying, Ms. Jones, there's no triangle. Well, actually there is. If I were to take these 2 points, I could create a triangle. So this looks similar to when we were doing rise over run. You know, when we would take 2 points and I would count up so many and over so many and get to my new point. So we can do the same thing when we're looking at this. It's very similar to rise over run and finding the height and then how far it is across. So if we look at the side going up and down, we can tell that it's going by one box. So I'm going to put a 1 over here. And then across, I'm going to count how many squares it goes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to have a 9 across. Now you're like, Miss Jones, I don't understand. Now what can we do? Well, remember when we drew the right angle in the side and we said that across from that was C. So we have the numbers to solve it with Pythagorean theorem. So up and down is my altitude, which is A. So I'm going to put a 1 here. The other number is B, and we're solving for C, the diagonal. 1 squared, 1 times 1 is 1. 9 squared, 9 times 9 is 81, equals C squared. Can I add them together? Yes, I can. 81 plus 1 is 82. So then I can take the square root. I'm left with 9.06. So that is the length of my diagonal. Now, what I'm going to take a look at here is the points, because we can actually do it. We've already done the subtraction that talks about in this equation, but we're going to look at it as to why it works. So let's call this point 1 and this point 2. So x2 on point 2, I'm going to go over, is -5 minus x1 is 4. -5 minus 4 is -9. And then I can square it. Well, when I do a negative, -9 times -9 is still going to be equal to 81, which is what we got when we did Pythagorean theorem. I then can do y2 minus y1. Well, y2, I start with the second point, was 1. The y of the other point, of the first point, is 0. 1 minus 0 is 1. So I have 1 squared, just like we did before, which equaled 1. And we said 81 plus 1 equaled 82. So we did the subtraction of these 2 points by counting how many spots up it goes. So it's really up to you how you would like to do this, if it works better with Pythagorean theorem or doing the distance formula. All right, let's look at the next one. So here we go. We can draw a triangle. Oop, didn't mean to do that. Okay, so remember, here's my right angle. Across from that is C, so A and then B. So A going up and down is 1, 2, 3, 4, 5, 6, 7. So I have 7 squared plus B, which is 1, 2, 3, 4, 5, 6. So 6 squared equals C squared. Now, what should happen is if I looked at let's say this is point 1 and this is point 2. Well, x2 is, let's see, negative 5. x1 is 1. Negative 5 minus 1 is 6. Negative 6. Negative 6 times negative 6 equals 36. Oops. Well, that worked too. All right, let's try the y's. Y squared, y2, which is, see, negative 5, minus y1, so y1 is negative 2. Minus a negative 2, hold on, negative 2. Oh, hold on, I made a mistake, guys, sorry about that. It should be positive 5 minus a negative 2. My apologies. So 5 plus 2 would equal 7 squared. Just like we got up here, 7 squared, which would have been 49. 49 plus 36 would have been 85. Take the square root, just like we have always done, and I would have had 9.22 as my diagonal. All right, so now we're going to take a look at how to put all of this in under this radical. So we're going to start with this. It says find the distance between B and C. All right, so we're going to label B as 1 and C as 2. So B, ordered pair, is 1, 2, 3, 4, comma, 1, 2, 3, 4, 6. So this is point B. Point C is 1, 2, 3, and negative 1. Okay, so remember my ordered pair is always X, comma, Y, every time. So we said C was going to be 0.2, so we're starting with x2 and x1. So x2 would be 3 minus x1 is 4. And I'm going to add the y2. Well, C we said was going to be 0.2, so that was going to be negative 1 minus 6. So from there, 3 minus 4. I'm going to keep my radical. 3 minus 4 is negative 1. Negative 1 minus 6 is negative 7. Now let's make sure that our numbers are right. So if I were to draw in a triangle, it is 1 across. And how many squares up it goes? 1, 2, 3, 4, 5, 6, 7. So we are good to go. So negative 1 times negative 1 is 1. Negative 7 times negative 7, 49. 1 plus 49 is 50. The square root of 50, 7.07. All right, let's look at number 5. So now we're looking at point A to point C. Let's call point A point 1, point C point 2. So A and C. Remember, it is X, comma, Y. So for point A, X, 1, 2 is negative 2, 3. C is 1, 2, 3, negative 1. All right, so let's do our distance formula. X2, so we said point C is the second point, and my x-coordinate is 3. So I'm going to have 3 minus the x-coordinate of A is negative 2. Then plus C for Y is negative 1. Oops. Minus the A Y coordinate is 3. Not quite. There we go. And there's a square. All right, so 3 minus a negative 2 is 5 squared. Negative 1 minus 3 is negative 4, and square that. So let's check our numbers, make sure our numbers are correct. So I'm going to erase this diagonal because it doesn't look good. All right, so here is 1, we go to here, and we go to here. All right, so let's see, up and down we have 1, 2, 3, 4. Across you have 1, 2, 3, 4, 5. So our numbers are good. Check plus. All right, so 5 squared, 5 times 5 is 25. Negative 4 times negative 4 is 16. 25 plus 16 is going to be 41. I take the square root of 41 and I get 6 decimal point 4. All right, we have one more. Now we're going to find the distance between A and B. Actually, let's use the straight line tool. Okay, so there's A and B. Let's use A as 0.1, B as 0.2. So we have A and we have B. Remember, sorry, we've been using C the last couple times, so I put C. Remember, it is always X, comma, Y is the order. So X2, we're looking at B, so let's find my X and Y for B. So 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. So B is going to be 6. 1, 2, 3, 4, 4, 6. 4, comma, 6. All right, and A is going to be, that's over negative 2. 1, 2, 3. All right, so here's my distance formula. We're using x2 minus x1. So x2, we said B was going to be 2, so I'm going to have 4 minus a negative 2 plus, then my y coordinates. So because I started with 4, which is point B, I have to use 6 minus 3 and square that. All right, so let's simplify a little bit. 4 minus negative 2. So I can change that to addition, which makes this 6 squared, plus 6 minus 3 is 3. So let's make sure our numbers are correct. So let's draw in a triangle. All right, so up and down I have 1, 2, 3. Well, the 3 checks out. Across I have 1, 2, 3, 4, 5, 6. So we are good. We did a great job. That was supposed to be a check mark, but you can't quite see it. Do it right there. Awesome. Okay, so our numbers work. So now we just need to do some squaring. So 6 times 6 is 36. 3 times 3 is 9. 36 plus 9 is 45. Square root of 45 is equal to 6 decimal point 71. All right, so that is it for distance formula. It is very similar to Pythagorean theorem. It's using the same concepts. They're just showing you in a different way on how to solve it. So I hope this helps, guys. This was for lesson 2, distance formula.